In this chapter, we will be exploring topics in set theory. In this lesson, we will be looking at Venn diagrams with three sets.
All right, so in this lesson here, the difference being that we're going to move on and look at what happens when we include another circle, another set. Okay? So to start off with, we're going to just complete this table here. We're going to just work through some problems here. And essentially what we're going to do is just discuss the terminology and the notation that we've already seen, we're already familiar with, and just transform it over into a three-dimensional, or sorry, not three-dimensional problems, but problems with three circles. So now, for example, set notation A intersection B, okay, A and B or whatever, we're going to shade that on this graph here. Now, notice that I've got three sets here, but when I ask about A intersection B, I don't care that there's a C here. It makes absolutely no difference to me. When I talk about A intersection B, I am only talking about the part that overlaps those two. So it's just this bit right there. Yes, I have highlighted or I have shaded in a part of C, but so what? It doesn't matter. The issue here is that what I shaded was the overlap between A and B. Okay, now if I come over here, this one says A union B or A or B and so on. And again, I noted that there's a third set here, but that's irrelevant. That's not a significant part of the problem here. I don't mention C here, so I don't know why that would throw off people, but it does. It does. Typically people will look at it and go, but what do I do about C? And the answer is nothing. When it says A or B, what I'm going to do here is I'm going to highlight A and I'm going to highlight B. I'm going to shade those guys in. Did I shade a little bit of C? Yeah, but the only parts I shaded of C were the parts that intersected with A and B. Okay, or A or B, I should probably say. That makes more sense. Now, come down here. Okay, now we're going to talk, it's a little bit different here. A intersection, not B. Okay, well, I'm going to do it like I did before here. I'm going to cover up B here. Now, not B is everything outside of this. And I want A intersection, not B. Well, okay, where that overlaps here is going to be this portion of A, okay, that I'm not covering with my thumb. And that's going to look like this. Okay, so A intersection where it overlaps with not B. And again, I know that I've shaded a little bit of C in there, but that's okay. C is just this extra set in there. I don't even know what the definition is. So, you know, don't even bother concerning yourself with it. Now we got to concern ourselves with C. Now watch this. This is A intersection B. So we've already identified what that is. That's this shaded portion right here, A intersection B. And now I'm interested in where that intersects C. In other words, where do all three of these guys intersect? And the answer is right here in the middle. That is where all three sets intersect. Okay, because now I've mentioned C, now I have to consider that set C. Okay, let's go down here. Oops, right here. A union B, now we've already identified that that means shading in those sets. Union C. So now we're just including another set there. So now what I'll do is I shade, but I do the same thing I did before here with union. Okay, I'm going to shade A, there we go. Union B means now I'll shade B. Union C means now I'll shade C, all of C. So there we go. There's A union B, union C. Okay, now the complement of A prime. Now you can't hardly see that there. That's really small here. I'll just make that a little darker. It's supposed to be A. Oh, you can't hardly see that now. A prime there. The complement of A. Now that's everything outside of A, right? Now it doesn't matter what's going on. When I see A prime there, or A apostrophe, that's everything outside of A. I don't care what it is. Okay, don't care what it is. I know I'm shading over B and I'm shading over C. And that's okay. That's okay. The only parts of B and C that I don't shade over are the parts that are going to be inside A, because those two, well, all of these pieces here are in A. So I would only be shading the parts that's outside of A. Now, here, you got to be careful when you read this. This is a little different than the one we did a couple minutes ago. This is A union B primed. Okay, so A union B primed. Now what I'm going to do here is I'm going to shade A, and then I'm going to shade B primed, or not B. Now, and we've commented on this before, and I know this causes a little bit of confusion here. I'm going to shade A. Now remember what union means. Union is like an or, okay? So I'm interested in something either being in A or being in not B. So now I'm going to shade in not B. Now the problem that most people bump into when they do this is they get frustrated by the fact that I've shaded this part in right here. They'll say, well, wait a minute, that is B, you're supposed to shade not B. But the mistake in thinking there is, the mistake you're making is that you're assuming intersection. This didn't say A intersection not B. Okay, it didn't say where A overlaps with not B. It's A together with not B, A or not B. So the reason why I shaded this is because if I pick an element right here in this section right here between the two, that is A, and that's part of this statement. Statement here, something in A satisfies this. As long as it's in either A or not B, it's good. So yeah, this is in A. So it's good. So you shade both of those sets. Now, over here, A union, not B, union, not C. Okay, A union, not B, union, not C. Now, I know you probably can't see those, but there are little apostrophes there, okay? All right, here we go. So A, we're going to shade A first, because with union, you just shade those sets. A. Now I'm going to shade not B. Okay, well, not B is going to cover a lot. Okay, not B. Oops. So I'm going to shade everything now outside that circle for this one. Oh, a lot going on there. Now, but I've also got to shade not C. So I have to shade outside the C circle. So I'm shading outside the C circle, shading outside the C circle, shading outside the C circle. There we go, look at that. So the only part that didn't get shaded in is the part here that is B and C, but not A, right? Just this little portion right there, okay? Because I shaded everything that was either A, not B, or not C. Again, the best way to do this is just to shade each one of those guys separately. When it's intersection, you shade the overlap. When it's union, you just shade them separately, and then you won't make the mistake there. Don't start getting frustrated. We're like, but I can't do this, blah, 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 blah. No. Shade them all separately. You get it done. Over here, A intersection B, union C. Now again, union means I'm going to shade this set and I'm going to shade this set. Well, or I said together. So A intersection B, where they overlap, that's this bit right here. Okay, where A and B exist together. Now I'm going to shade C, because there's my union there, my or, and C looks like this. Okay, and there we go. So that's what that particular set would look like. Come over here, and now this is going to be A intersection, okay, B union C. Okay, now let's just think about this, because I got to shade where they overlap. Okay, where A intersects B union C. Now B union C would be both of those two sets together. Okay, now here's A. So it's going to be these two sets together, overlapping with A. So it's got to look something like this. It's got to be that piece right there, because that's where the union of B and C intersect with A. It's got to be just that little section right there. So it helps to think of it like this, like see the B union C, and then look at where A crosses over that. Okay, now I hope it helps to go through those examples there to see how the shading works. We're going to do some more examples now, word problems. We're going to give a context to this and then answer questions based on that context.
The Venn diagram displays the results of a survey of 100 students in a high school regarding technology in their personal lives. Answer the following questions if P represents the number of students with a cell phone, C represents the number of students with a computer, and D represents the number of students with an iPad.
Okay, so this question basically amounts to just asking us to interpret a Venn diagram with three circles in it. So over here we're told that this circle represents students with a phone, computer, iPad. So the first question here is how many students own only a cell phone? Now, only a cell phone is the part of the cell phone set here that doesn't overlap the others, and so the number in there is 3. So that is only a cell phone, okay? How many students own a cell phone? Now that's a different question because in that case, I don't care about the overlap. So 3 have only a cell phone, 1 have a cell phone and a computer but no iPad, 6 have all 3. And then 1 over here has a phone and an iPad, phone and iPad? Yeah, iPad, but no computer here. So now 3 and 1 is 5 and 6 is 11. So there are 11 students represented in that set of students that have just a cell phone. That have a cell phone, not just a cell phone, but have a cell phone. How many students own a computer and an iPad? Okay, well, computer and an iPad. Now I'm talking about the overlap between the two. Now that's this part right here. Now, these 6 people here, granted, they also have a cell phone, but they do. They have a computer and an iPad. Doesn't matter that they also have a cell phone. So what? The question was just, do they have a computer and an iPad? Yeah, so there's 6 here that have all 3, 2 that don't have cell phones that have just the computer and the iPad. And altogether, that's going to be 8. Okay, the next one. How many students own a computer and an iPad only? Well, we were just talking about that. A computer and an iPad only. So in other words, we're saying no cell phone there. So we're canceling this part out here. And so in that case here, this is the part of the set that's overlapping between those two, but doesn't include the cell phone. And so the answer here is 2. How many students own a computer or an iPad? Okay, now or refers to the overlap of the two sets, or the union of those two sets here. So in this case here, the only part of this that I don't really care about is the part, the number of students that own only a cell phone, and actually out here, the ones that don't own anything. So in the union of these sets, I'm looking to add up all of these numbers right here. So what have I got here? We got 68 and 2 is 70, 77, 77, 1 is 78, and then you got 78 and 17 is going to give us, what is that, 95 it looks like. So we've got 95 students, okay, who own a computer or an iPod, or an iPad, I guess is what they say there, iPad. How many students own all 3 items? Okay, well that's the intersection of all 3 sets, and that's right there in the center, and we can see that that's a 6. And then finally here, what does the 2 outside the 3 circles represent? I'm talking about that 2 right there. Well, notice that this is the one that's outside all these. These 2 people aren't in any of these sets. So these are 2 people who do not own, okay, a cell, a computer, or an iPad. They've got nothing. That's fine. That's it.
240 students were surveyed to determine which restaurants they like. 90 like Chicken and More, 90 like Fast Pizza, 90 like Gigantic Burger, 37 like Chicken and More and Fast Pizza, but not Gigantic Burger, 32 like Chicken and More and Gigantic Burger, 11 like Fast Pizza and Gigantic Burger, but not Chicken and More, 13 like all 3 restaurants. How many students do not like any of these restaurants?
Okay, so we're given some information about a group of students, a group of 240 students. Okay, and that's important to notice here, it's 240. So what I might do here is just put a little box on top here. My universe consists of 240 students. Now what I'm going to do is I'm going to fill in this Venn diagram identifying the number of students in each one of these sets and subsets. Okay? Because in any given set here, particularly these guys right here, we're looking at actually 4 different subsets. There's, in this case here, like gigantic burger, there's the subset of people that are just gigantic burger, the subset that are just chicken and more and gigantic burger, all 3, or just the gigantic burger and the fast pizza there that I'm seeing. Anyway, we're going to fill these all in just a second here. Now, I've got 90 like chicken and more, 90 like fast pizza, 90 like, hey, when we talk about it all like this, in like giving numbers into that entire set, that's actually not all that useful. I got to kind of go down this list here. I'm looking for all 3, and there it is. 13 like all 3 restaurants. There we go. That's helpful information. So 13 go in the center, in the overlap of the 3. Now, I'm going to work my way up. 11 like fast pizza and gigantic burger, but not chicken and more. So they like fast pizza and gigantic burger, so that's an overlap, but not chicken and more. Okay, so that's essentially, that's going to be the overlap here, excluding chicken and more, and we're told that that's 11. Okay, that's kind of cool. So now I've got this, I've got this. 32 like chicken and more and gigantic burger. So chicken and more and gigantic burger. 32 are in this subset. But there's another division inside there. There's already 13 in a subset in there. So there should be 32 in this whole group, but I've already got 13 accounted for in there, which means there are 19 that are unaccounted for. Okay, so these 19 people like chicken and more and gigantic burger, but they don't like fast pizza. Okay, so that's this piece right here. 37 like chicken and more and fast pizza, but not gigantic burger. So they like chicken and more and fast pizza, but not gigantic burger. So they like this is in this subset right here, this intersection, but we're excluding this little part right here. So they're just this, and there's 37 there. Okay, now we move up. Okay, and I just checked that off. Now we're going to move up here. 90 like gigantic burger, which means in gigantic burger, there should be 90 in this set right here. So I've already got, of the 4 subsets here, I've already got 3 taken care of. There's 19 here, there's 13 here, and there's 11 here. So if I take 90 and subtract those pieces, I get 47 that like just gigantic burger. So that's this right here. 90 like fast pizza. Okay, fast pizza. So this set right here, there should be 90 in there, and there are 4 subsets. So to figure out what's in right here, the only fast pizza, I'm going to subtract those totals there. So 90 minus 37 minus 13 minus 11, and that's 29 people like just fast pizza. And there we go, got rid of the fast pizza bit there. And then 90 like chicken and more. Okie dokie. So in this set right here, there should also be 90. Okay, and again, there are 4 subsets here. 3 of them I already know, so I'm going to subtract the 37, subtract the 13, subtract the 19, and I'm going to be left with 21. And that 21 represents the people that like just chicken and more. Okay, and there we go. Now, question is, how many do not like any of these restaurants? Oh, okay. Okay, well, there should be 240 students total represented here. So what I'm going to do here is I'm going to add all of these up. So if you add the 21 and the 37 and the 29 and then the 19 and the 13 and the 11 and the 47 there, this accounts for 177 students. So you've got chicken, union, fast pizza, union, gigantic burger. If you look at how many is represented there, that is a total of 177 people. But there should be 240 there. So if we take the difference between 240 and 177, there are 63 people who sit outside those 3 there were those three sets here, and so there are 63 people who don't like any of those.
Each member of a sports club plays at least one of soccer, rugby, or tennis. Answer the following questions given the following information. 43 members play tennis, 11 play tennis and rugby, 7 play tennis and soccer, 6 play soccer and rugby, 84 play rugby or tennis, 68 play soccer or rugby, and 4 play all three sports.
Okay, now in this question here, just to be clear, the bit of information that actually it seems like they just kind of throw it out there, but it's really important. It says each player plays at least one of these sports here. Now the reason why that's significant is because when I start to fill in this Venn diagram here, I will know right away that there's nobody who sits outside of all of those. There's nobody out here that doesn't play any of those. That's what that's trying to state there. Okay, now I'm going to look at the data that's given to me, and remember, I'm not going to start with the totals here. I'm going to start with the inside. The 4 play all three sports. So right there's my 4. Now, I am told that here, 68 play soccer or rugby. Okay, soccer or rugby. That means when I add this, I get 68. Okay, that's a lot of unknowns here. That's actually not all that useful to me right now. Okay. 84 play rugby or tennis. Oh boy. Well, that's this plus this plus this plus this plus this plus... Well, that's a lot of unknowns still. Okay, that's not helping me. Now, here says 6 play soccer and rugby. Okay, here we go. Soccer and rugby. Well, that's this interval right here, or this set right here. But notice that set can be broken up into 2 parts, and 4 of them are in this part. Now, if there's supposed to be 6 total there, that's got to be 2. Okay, good. I made some headway there. The next part it says here, it says 7 play tennis and soccer. Okay, tennis and soccer. Okay, that's this subset right here, and it's broken up into 2 parts. There's already 4 people accounted for, so that means there must be 3 right here, so that this overlap here comes to 7. Next here it says 11 play tennis and rugby. Okay, tennis and rugby, that's this bit right here. Again, it can be broken up into 2 parts here. I've already got 4 accounted for, so this must be 7 left over there. And then it says 43 members play tennis. Oh, okay. So 43 play tennis here. Okay. So now I have got, what is it? I've got 14 here accounted for. 3 and 7 is 10 plus 4 is 14. But there should be a total of 43 when you add up all of those numbers, because these are all subsets of tennis. So 43 minus 14 is going to give you 29. Okay, now I can go back to some of these other bits of information that are actually kind of useless to me. For example, if I go 84 played rugby or tennis. Okay, 84 played rugby or tennis. You add those all up there. Well, I can take that 84, and if I subtract everything here, okay, I will subtract everything that's in the tennis and then even this little bit left over here, and I will get that there are 39 left over. Okay. And then I know that 68 play soccer or rugby. Okay, so what is that? 68 there. Now, that's going to be, I'm going to take from 68, I'm going to subtract the 2, the 4, the 3, I will subtract the 7, and, whoops, sorry, I'm just doing this in the calculator over here, 7 and the 39. And that leaves me with 13 that play just soccer. Good. Now, there's my Venn diagram all filled in here. Okay, good. That's the first part here. Now, how many members does the club have? Now, I'm going to be super lazy about this when I do this, because notice what I was told here. I was told 84 play rugby or tennis. 84 play rugby or tennis. I already know the sum of this and this altogether is 84. The only number that's not there, that's not included in that, is this 13 that's playing just soccer. Okay, so I'm going to take advantage of what union means, this or this, which takes into account all of these little subsets, and I'll just add the one that's missing. So 84 plus 13 tells me that there are 97 people in this club.
At Happy Time High School, 185 grade 11 students were surveyed to determine which soft drinks they like to drink. 115 drank Coke, 92 drank root beer, 100 drank orange, 18 drank Coke and orange only, 52 drank root beer and Coke, 57 drank root beer and orange, and 25 drank all three. Now answer the following questions.
Okay, so to start off with, we're going to start putting all this stuff on the Venn diagram just like it asks here. And again, we're going to try really hard to start in the center here. So 25 drank all three. So 25 will go in the center there. Now, let's go backwards here, because usually the easiest way to do this is to go backwards. This next one here says 57 drank root beer and orange. Okay, so 57 drank root beer and orange. So that's this overlap right here. And what we'll do is we'll take that 57, there should be 57 here, but that part is broken up into two subsets, 25 of which is already there. So 57 minus 25 gives us 32. So there's 32 students that drink just root beer together and orange. Okay, so that's that second bit of information. Now I'll go backwards a little bit more. 52 drank root beer and Coke. So 52 are going to be in this little bit right here. So what we'll do here is we'll take that 52 and we're going to subtract that 25 that's sitting right there. And that gives us 27. So the total number of people in root beer and Coke is 52. Then we can come over here and we can say, okay, we've dealt with that. Good. The next one that we've got here says 18 drank Coke and orange. 18 drank Coke and orange. Oh, thank goodness. Okay, I had a brief little panic attack because I read 18 drank Coke and orange. Let me tell you why I was having a little bit of a moment here. Because it is not possible that the overlap of Coke and orange, okay, so Coke and orange, it's not possible this could be 18 if a subset has 25, has more than 18 in it, okay? The total of these two little subsets here should be more than 25 here. Now, if that's supposed to be 18, I run into a problem. Thank goodness for this little word at the other end of this line here that says only. Okay, well, right here, this piece right here is Coke and orange only. So I can put 18 right there. In this case, that fits because of the word only. Okay, well, I'm happy about that. Now I can go through and fill in the rest of this. 100 drank orange. Okay, so where's orange here? Here's orange. So 100 drank orange. So that's all four of these little subgroups. So I'm going to subtract from 100 the 18, the 25 from the center, and the 32 there. And that's going to leave me with 25 left over that drink just orange. So that's gone. 92 drink root beer. Okay, so this whole set here has 92 students, but it's broken up into four subsets. So I'm going to subtract the totals from the different subsets. So I'll subtract the 27, the 25, and the 32. And that leaves me with just 8 that like root beer, only root beer. And then we've got 115 that like Coke. So 115, and then we're going to subtract what's left over here. So minus the 27, minus the 25, minus the 18 from those subsets, and that leaves us with 45 out there that like just Coke. Good. Now we filled that all in, except for one little thing. Except for one little thing here. We're told that there are 185 students in this universe. Okay, so here we go, 185 students total. There's one more set here that we haven't addressed, and that's outside that. So what I'll do with that is I'll take that 185, and I'm going to subtract all of these different sets here. Okay, so I'm going to subtract everything here in Coke with the things left over, root beer, and the 25 here in the orange. And that's going to leave me with 5 students out here that actually don't like any of those. So with that information here, I can come over and answer the rest of these questions here. How many students drank only Coke? Well, only Coke is this subset here of Coke. Okay, and that's going to be 45, the part of the Coke set that doesn't overlap anything else. How many drank Coke or root beer? Okay, Coke or root beer is going to be everything, all the little subsets that are in either Coke or root beer. That's 1, 2, 3, 4, 5, 6 little subsets here. And so we're just going to have to add that all up. It turns out that leaves us with a lot. That's 155 people when you do that. Okay? Now, the way I did that here, I got a little bit lazy. I knew that there were 185 in the whole thing. And so what I did was I just subtracted the 5 and the 25 because those are the two groups that aren't part of that. And I got 155. And how many did not like to drink any of those 3 drinks? Okay, well, we spent a little bit of time at the end there to figure that out. Found out that was 5. Good. There we go.